India is no stranger to heat, yet recent years have ushered in an era of unprecedented, scorching temperatures. These intense heat waves are no longer just a seasonal discomfort. They are a silent threat, silently baking the very structures we inhabit. Our buildings, often constructed with reinforced concrete, are facing an invisible enemy. Reinforced concrete, a staple in modern construction, is vulnerable. It's a composite material, a blend of concrete and steel. Concrete, strong under compression, holds the weight. Steel, robust under tension, provides flexibility. Together, they form the backbone of our buildings, bridges, and roads. But this partnership weakens under extreme heat. Like an overstretched rubber band, the steel loses its strength. The concrete, no longer adequately supported, begins to crack and crumble. Across India, buildings are exhibiting the stress of relentless heat. We need to pay attention before it's too late. The distress signals are evident, etched onto the faces of our buildings. Cracks, often hairline at first, appear near windows and door frames. These openings, seemingly insignificant, widen with time, allowing water to seep in. What starts as a minor inconvenience can escalate into major structural damage. The constant cycle of heat expansion and nighttime contraction weakens the concrete. Leakages, another telltale sign, often manifest on roofs and ceilings. Water, finding its way through the compromised concrete, stains the ceilings and drips down walls. This not only damages the aesthetics of a building, but also creates a breeding ground for mold and mildew. Schools and hospitals, essential for a functioning society, also bear the brunt of these heat-induced flaws. These issues highlight a systemic problem, a lack of consideration for extreme heat conditions in our building practices. The science behind these failures is straightforward. Concrete, when exposed to high temperatures, undergoes thermal expansion. It swells, like bread rising in an oven. Steel, embedded within the concrete for reinforcement, also expands but at a different rate. This difference in expansion creates internal stress, pushing and pulling against each other. This internal struggle weakens the bond between the concrete and steel. Over time, this bond, crucial for the structure's strength, begins to fail. The steel, no longer fully anchored, becomes susceptible to corrosion. Rust weakens the steel, further compromising its ability to provide the necessary tensile strength. This process, a silent and invisible deterioration, can continue for years before the visible signs of damage appear. In many parts of India, locally available aggregates are used to keep costs down. However, some of these aggregates react poorly to high temperatures, exacerbating the internal stress within the concrete. While the science behind these failures is clear, the responsibility doesn't solely lie with the materials. Construction practices, often rooted in tradition and cost-cutting measures, play a significant role in exacerbating the problem. The lack of skilled labor, particularly in overseeing and implementing proper construction techniques, contributes to the vulnerability of our buildings. One critical area of concern is the placement and compaction of steel reinforcement bars, rebars, within the concrete. Rebars act as the skeleton of a concrete structure, providing tensile strength. However, if not placed and compacted correctly, they can become weak points, prone to corrosion and failure. Inadequate concrete cover over the rebars further accelerates this process, exposing them to the elements and increasing the risk of rust. The blame doesn't rest solely on construction practices. The design phase, the blueprint from which a building rises, also needs scrutiny. Many buildings in India, particularly residential structures, are built without the involvement of qualified structural engineers. This lack of expert oversight often translates into designs that are ill-equipped to handle the specific challenges posed by India's climate, particularly the increasing frequency and intensity of heat waves. Building codes and regulations, designed to ensure structural safety and resilience, are often outdated or not rigorously enforced. This allows for the construction of buildings that may meet the minimum requirements on paper, but fall short when faced with real-world challenges like extreme heat. The lack of regular inspections and maintenance further exacerbates the problem, allowing minor issues to fester and grow into major structural concerns. To grasp the urgency of the situation, we need to look beyond the immediate cracks and leaks. We need to analyze the trend. Data from meteorological departments across India paints a clear picture. Temperatures are rising, and they're doing so at an alarming rate. The past few decades have witnessed record-breaking heat waves, each one pushing the boundaries of what our infrastructure can handle. These rising temperatures are not isolated incidents. They are part of a larger global trend of climate change. As greenhouse gas emissions continue to rise, we can expect more frequent and intense heat waves in the future. Our buildings, designed for a different climate reality, are ill-prepared for this hotter future. Ignoring this trend is akin to ignoring a crack in a dam. The consequences will be severe. This is not just about discomfort, it's about safety, habitability, and economic stability. India is not alone in this struggle. Countries around the world, particularly those in tropical and subtropical regions, are grappling with similar challenges. From the crumbling concrete facades in the Middle East to the buckling roads in Australia, the impact of extreme heat on infrastructure is a global concern. This shared experience, while alarming, also offers an opportunity for collaboration and knowledge sharing. Learning from the successes and failures of other nations can provide valuable insights for India. For instance, countries like Singapore and Malaysia have made significant strides in developing and implementing climate-resilient building technologies and practices. Sharing knowledge, best practices, and technological advancements can accelerate the adoption of climate-resilient construction methods worldwide. The challenges are significant, but so are the solutions. Advancements in material science and engineering offer promising avenues for building more resilient structures. One such avenue is the development of high-performance concrete. This type of concrete, engineered to withstand higher temperatures, offers improved durability and longevity. By using different types of cement, aggregates, and admixtures, engineers can tailor the properties of concrete to better suit specific climate conditions. Another promising area is the use of phase change materials, or PCMs, in construction. PCMs absorb heat during the day, preventing it from penetrating the building, and release it at night, keeping the interiors cool. Incorporating PCMs into walls, roofs, and even pavements can significantly reduce the heat island effect in urban areas. The consequences of inaction extend far beyond crumbling concrete and leaky roofs. A failure to adapt our construction practices to the changing climate will have far-reaching repercussions on our economy, health, and social fabric. The economic costs are perhaps the most apparent. As buildings deteriorate at an accelerated rate, the cost of repairs, renovations, and even reconstruction will skyrocket. This financial burden will fall not only on individuals, but also on communities and the government. Beyond the immediate financial implications, there's the issue of health and well-being. As temperatures rise and buildings become less effective at providing thermal comfort, the incidence of heat-related illnesses is likely to increase. This will put additional strain on our healthcare system and impact the productivity and well-being of the population. Furthermore, the displacement of communities due to unsafe housing conditions will lead to social disruption and exacerbate existing inequalities. The challenge before us is clear. We need to build a more resilient India, one that can withstand the silent threat of rising temperatures. This requires a multi-pronged approach, a collective effort from policymakers, engineers, architects, builders, and citizens alike. We need to move beyond the mindset of simply constructing buildings to creating structures that are in harmony with our environment. The first step is acknowledging the problem. We can't address a threat we refuse to see. We need to raise awareness about the impact of extreme heat on our buildings and the urgent need for change. This awareness needs to permeate all levels of society, from policymakers to the general public. Education and public awareness campaigns can play a crucial role in driving this change. The next step is to update our building codes and regulations. These codes, often outdated and inadequate, need to reflect the realities of a changing climate. We need stricter guidelines for material selection, construction techniques, and the incorporation of climate-resilient design principles. Furthermore, enforcement of these codes needs to be stringent and consistent to ensure that all new constructions are built to withstand the challenges of extreme heat.